Hello everyone, let's discuss organic Phillips from NCRT. A direct question of 2 or 3 marks comes from this part. So the very first question, addition of HBr to this unsaturated compound. So here we apply a Markovnic rule. According to the Markovnic rule, negative part, this Br part, get attached with the carbon which is having a lesser number of hydrogen. So in this case, H, and the Br part comes here and H here. Next is again a same Markovnic rule. Negative part get attached with a carbon having lesser number of hydrogen. So double bond changes to a single, Cl part comes here and H goes to terminal carbon. Now the next is a addition of HBr in presence of peroxide. So this one is a anti-Markovnic rule. In case of anti-Markovnic rule, negative part get attached with a carbon which is having a more number of hydrogen. So the part comes here and the hydrogen to the non-terminal carbon. Next is a reaction of alcohol with thionyl chloride. So in this case, OH group, OH part, that one is replaced by Cl. Next, bromine in the presence of heat or ultraviolet light, that is in the presence of sunlight. This reaction is a photochemical halogenation reaction, which is an exclusive reaction of an alkane. So in this case, Br part get attached with a benzylic carbon, major product. So in this case, H of benzylic hydrogen is replaced by Br. Next, HCl. So we are having two OH groups here. This OH group is alcoholic, whereas this one is phenolic because it is directly attached with a benzene ring. So alcohols are more reactive than that of phenol. In case of phenol, because of the plus R effect, a partial double bond character is there. That's why nucleophilic substitution reaction doesn't take place easily in this case. So OH and this OH, that one is replaced by Cl here. Next we have Hi. Again we apply a Markovnic rule. So according to the Markovnic rule, negative part get attached with a carbon which is having a lesser number of hydrogen. Double bond changes to a single bond. Iodine come here and H part goes to this carbon. Next is Finkelstein reaction. So Br is replaced by iodine here. Then next is again a photochemical halogenation reaction because the reaction is in the presence of a sunlight, and this carbon is allylic carbon. So the negative part, this Br get attached here. Next is a Grignard reagent reaction. So A is cyclohexyl magnesium bromide. Grignard reagent with water. This result in the formation of MgBr, that one is replaced by hydrogen here. RBr plus Mg in dry ether, the resulting is RMgBr, alkyl magnesium bromide. D2O, D2 is a heavy water, deuterium. So R here is this part. This part is R. Then R prime X in the presence of magnesium, that forms a Grignard reagent, R prime MgX, R prime MgX. This R prime MgX with water, it gives R prime H here. He is a R prime H part. Next reaction is a Wurtz reaction, which is a doubling of RR. It means two R's get attached with each other. It means in this case, R part is this. Tert butyl is a alkyl part here. Next reaction, a reaction of CH3, CH2, Cl with Na. This one is a Finkelstein reaction. So Cl, that one is replaced by I here. CH2, I we have. Next we have reaction of tert butyl bromide with alcoholic KOH. This one is a beta elimination reaction which result in the formation of dehydrohalogenation takes place. So this result in the formation of alkene here. Next, CH3, CHBr, CH2, CH3, NS nucleophilic substitution. This Br is replaced by OH here. CH3, CH, OH, CH2, CH3. Next, again a nucleophilic substitution reaction. Br is replaced by Cn here, CH3, CH2, Cn. This one is again a nucleophilic substitution reaction. So NaCl is the byproduct and the product major formed is C6H5COC2H5. Reaction of alcohol with thionyl OH group is replaced by Cl here. So in this case, product is CH3, CH2, CH2, Cl. Next we have peroxide reaction. So in case of peroxide, addition reaction takes place and the negative part get attached with a carbon which is having a more number of hydrogen. So in this case, this Br comes here and H part. Next is a HBr. In the absence of peroxide, so this one is a Markovnikov of reaction, negative part get attached with a carbon which is having a lesser number of hydrogen. It means Br attached with this carbon only. Next is the hydrolysis of alkene. So in this case, it again follows a Markovnikov rule. So OH part get attached with a carbon which is having a lesser number of hydrogen. Now the next reaction, that one is a reaction with sodium borohydride, which is a weak reducing agent than that of the lithium aluminum hydride. It doesn't affect ester part. That remains as such. So sodium borohydride changes the ketonic part, carbonyl part, into alcohol, and the ester part that remains as such here, CH2, CH2, COO, C2H5. That remains as such. Just a minute. So here the product is keto group, it changes to OH and ester part remains as such here. Then next again a reaction with sodium borohydride. So carbonate it changes into the alcoholic part in presence of sodium borohydride. CH2OH. Next reaction with C2H5COCl anhydrous AlCl3. This is basically a Friedel-Crafts acylation reactions. In this case, product formed is H of the benzene ring. That one is replaced by C2H5CO. HCl is the byproduct. So COC2H5. Next, dialkyl cadmium with acetyl chloride. This result in the formation of ketone CH3CO, CH2, C6H5. Next reaction is a oxymercuration demercuration reaction. It is basically a grade 11 reaction in which a proton shift takes place. So this result in the formation of acetone. Last 25th reaction, it is an Itard reaction. In Itard reaction, CH3 part in the presence of CrO2, Cl2 and hydronium ion, it changes to a aldehyde part. Why aldehyde is formed here? Because of the geminal reaction intermediate. Now the next reaction, that is the reaction of carbonyl with ammonia and its derivative. So in this case, loss of water is there and double bond NOH, oxime formation takes place. In second case, again loss of water, oxygen of carbonyl and the two hydrogen from the amine part are removed. This one is a 2,4-dinitrophenylhydrazine. So this result in the formation of double bond N NH hydrazone. Next we have aldehyde with semicarbazide. It has two amino group. This one is involved in resonance, so it doesn't participate in a condensation reaction. This one is a free amino group. So oxygen of carbonyl and the hydrogen of amino group are removed and the resulting product is RCH double bond CH CH double bond NNH and this is attached with the CO NH2 part. CONH2 is here. Next we have H2 from here and the oxygen of carbonyl, that one is removed. So the resulting is C double bond N CH2CH3. Next reaction with the alkaline KMnO4, which is an oxidizing agent. So in this case, it forms the complete alkyl chain. That one it changes into a benzoic part COK, and this on hydrolysis in a presence of H plus it changes to a benzoic acid. Then next we have a reaction with a thionyl chloride. So thionyl chloride, what happens here? OH, that one is replaced by Cl. So COCl. Next we have again a reaction of carbonyl with a ammonia and its derivative, and this one is a semicarbazide. It has two amino groups at the terminal, but only one participate in a condensation reaction. This one is the most important reasoning question frequently asked from carbonyl compound. So this carbonyl, this one is involved in a resonance with, so only, and this one is free to undergo condensation reaction. So here the product is C6H5 CHO CH double bond N NH CONH2. Next is benzene changes to benzophenone. This we do with the help of a benzylation reaction. COCl anhydrous AlCl3 here. Next reaction That one is a reaction of Tollens reagent. Tollens reagent is a mild oxidizing agent. It changes CH to COO. This part is formed here. Then the next reaction is a reaction of carbonyl with HCN, NaCN and HCl that combines with each other to form HCN. So carbonyl react with HCN to form a cyanohydrin here. CHOHCN. Next reaction is, this one is a cross-aldol condensation. Absence of alpha hydrogen here. So in this case, this part acts as a nucleophile and the benzaldehyde part it acts as an electrophile here. Now the product is C6H5CHOH CHCHOCH3 cross-aldol product. Next again a reaction with the sodium borohydride. So it doesn't affect the ester part here. In this case the carbonyl changes into a alcohol. So the product here is CH3CHOH CH2COO C2H5. Next we have reaction with CrO3. CrO3 is a mild oxidizing agent, so it changes alcohol into a carbonyl part. Next we have formation of cyclohexyl carbaldehyde from double bond CH2 part. So this we do with the help of hydroboration. Oxidation reaction followed by PCC, selective oxidation. Next is formation of ketone with the help of O3 and zinc, reductive ozonolysis. So this one is obtained by combining the two cyclohexyl ring. Next is CH3, CH2, I with NaCN. So A here is I is replaced by CN, CH3, CH2, CN. Partial hydrolysis of this. So CN on partial hydrolysis changes to CONH2 part. CONH2 amide. Amide on Hoffman degradation reaction, Hoffman bromide degradation reaction. So amide changes into amine. So the product here is CH3, CH2, NH2, one carbon lesser than the parent one. Next is next we have a reaction C6H5 N2Cl with CuCN. This one is a Sandmeyer reaction. N2Cl is replaced by CN here. So in this case the product is C6H5CN. This C6H5CN on hydrolysis, complete hydrolysis changes into a COOH carboxylic part. Carboxylic group with ammonia form COONH4, and this on heating it gives a amide C6H5CONH2 part here. Next reaction CH3 CH2Br with KCN. So Br is replaced by CN. With lithium aluminium hydride it changes to a amine CH3 CH2 CH2 NH2, and this on reaction with nitrous acid, as it is an aliphatic one, it changes to a alcoholic part because aliphatic diazonium salt are unstable. Next C6H5NO2 with FeCl reduction. So NO2 changes into NH2 here. This NH2 with NaNO2 with HCl, this is a diazotization reaction, so it changes into C6H5N2Cl. And benzene disonium chloride on reaction with water, it changes into a phenol part, C6H5OH part here. Next reaction, CH3COOH with ammonia and heat. So A here is CH3CONH2. This on Hoffman degradation, bromamide degradation reaction changes into a CH3NH2. NaNO2 with HCl. This forms CH3N2Cl. And this CH3N2Cl is unstable in nature, so it changes into alcoholic part. C6H5NO2 with FeCl, that forms C6H5NH2. With nitrous acid, diazotization takes place, so it gives C6H5N2Cl. And this with alcohol, that gives an azodie. So it is phenol, hydrogen of this get removed, so N2 azodie, which is orange in color. An exclusive reaction of primary amine. This is a carbyl amine reaction. This results in the formation of isocyanide. Then the reaction with C6H5N2Cl with H3PO2, it changes into a benzene ring. C6H5NH2 with sulfuric acid, that result in the formation of sulfanylic acid. SO3H comes here. Then benzene disonium chloride with ethanol, it gives benzene. Aniline with bromine water, aniline NH2 group is highly activating group, so it gives 2,4,6 tribromoaniline. Tri substitution takes place here. C6H5NH2 is basically an acetylation reaction which we do for the protection of amino group, or you can say to reduce the activity of NH2 group by changing it into a acetanilide form. Last reaction, C6H5N2Cl with HBF4, and then with NaNO2 they give NO2, nitrobenzene. All these fill-ups are from NCERT, and a direct straightforward question of 2 or 3 marker comes from this part.